Alright, so in this problem, I have 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 333. So to solve this, I'm going to first start by factoring out 3 to the power of x. So I have 3 to the power of x times 1 plus 1 plus 1 is equal to 333. Now 1 plus 1 plus 1, that's simply equal to 3. So now I have 3 to the power of x times 3 is equal to 333. Now from here, I'm going to go ahead and divide both sides by 3. So then these two cancel out, and now I have 3 to the power of x is equal to 333 divided by 3, which is 111. Now if I take the log on both sides, I have log 3 to the power of x is equal to log 111. If I have something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, log 3 to the power of x, move x to the front. So then I have x times log 3 is equal to log 111. Now if I divide both sides by log 3, these two cancel out, and I have x is equal to log 111 over log 3. Now, log 111, this is equal to 2.0453, and log 3, this is equal to 0.4771. So I have x is equal to 2.0453 over 0.4771. So now this is equal to 4.2869. So this is my answer. Now to check, I have 3 to the power of x is equal to, 3 to the power of x plus 3 to the power of x plus 3 to the power of x is equal to 333. X is equal to 4.2869, so I have 3 to the power of 4.2869 plus 3 to the power of 4.2869 plus 3 to the power of 4.2869 is equal to 333. 3 to the power of 4.2869 is, if you add up all these, you get 333.0369, which is approximately equal to 333. So this is right. Alright, so in this problem, I have m to the power of 3 plus m is equal to 350. So the first thing I'm going to do is subtract 350 on both sides. So these two cancel out, and now I have m to the power of 3 plus m minus 350 is equal to 0. Now, m to the power of 3 plus m minus 350, well, I can rewrite 350 here as negative 343 minus 7. So now I have m to the power of 3 minus 347 plus m minus 7 is equal to 0. Well, m to the power of 3 minus 347, this is the same thing as m to the power of 3 minus 7 to the power of 3. And I have this plus m minus 7. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is the same thing as a minus b times a squared plus ab plus b squared. So in this case, a is m and b is 7. So I have m minus 7 times m squared plus 7m plus 7 squared. I have this plus m minus 7 is equal to 0. Now, 7 squared, this is the same thing as 49, so I have m minus 7 times m squared plus 7m plus 49 plus m minus 7 is equal to 0. Now if I factor out m minus 7, I have m minus 7 times m squared plus 7m plus 49 plus 1, which is equal to 50. So this is equal to 0. So now this gives me two equations. I have m minus 7 is equal to 0, and I have m squared plus 7m plus 50 is equal to 0. So m minus 7 equals 0. This is the same thing as m equals 7, so this is already one solution of m. And m squared plus 7m plus 50, you have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is the same thing as negative 7 plus or minus the square root of 7 squared, which is 49, minus 4 times a, which is 1, times c, which is 50. And if you notice, this is the same thing as the square root of 49 minus 200, which is going to be a negative number, meaning this won't work, and my only solution is m equals 7. All right, so in this problem, I have 11 to the power of 9x plus 11 is equal to 9 to the power of 11. So I want to find the value of x here. So for my solution, first start with 11 to the power of 9x plus 11 is equal to 9 to the power of 11. Now if I take the log on both sides, I have log 11 to the power of 9x plus 11 is equal to log 9 to the power of 11. If I have something in the form log a to the power of b, I move this exponent of b to the front. So this is equal to b times log a. So I can move 9x plus 11 to the front, and I can move 11 to the front. So now I have 9x plus 11 times log 11 is equal to 11 times log 9. Now if I divide both sides by log 11, these two cancel out, and I have 9x plus 11 is equal to 11 times log 9 over log 11. And now log 9, this is equal to 0.9542, and log 11, this is equal to 1.0414. So now if I plug these values in for log 9 and log 11, I have 9x plus 11 is equal to 11 times 0.9542 over 1.0414. Now 0.9542 over 1.0414, that's going to equal 11 times 0.9163, which is equal to 9x plus 11 is equal to 10.0789. So I have this minus 11. So now I have 9x is equal to negative 0.9211, meaning x is equal to negative 0.1023. Alright, so for this video, I'm going to be solving the equation x to the power of 4 is equal to negative 9. So what I'm first going to do is add 9 on both sides. So then these two cancel out, and I get x to the power of 4 plus 9 is equal to 0.
Now from here, I can rewrite x to the power of 4 as x squared to the power of 2, and I can rewrite 9 as 3 squared. And if I have something in the form a plus b squared, this is equal to a squared plus b squared plus 2ab. And if I have something in the form a squared plus b squared, then this must mean that this is going to equal a plus b squared minus 2ab, because this is the same thing as this without the 2ab. So this means that a is equal to x squared and b is 3. Going back over here, so I get x squared to the power of 2 plus 3 squared is equal to x squared plus 3 squared. And this turns into x squared to the power of 2 plus 3 squared is equal to x squared plus 3 squared minus 2 times x squared times 3 is equal to 0. So now from here, I get x squared plus 3 squared minus 6x squared is equal to 0. And remember how the square root of 6 squared is equal to 6. So what I'm going to do is I'm going to rewrite this as x squared plus 3 squared minus the square root of 6x squared is equal to 0. And the reason I did that is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So in this case, this turns into x squared plus 3 plus the square root of 6x times x squared plus 3 minus the square root of 6x is equal to 0. So this gives me two equations. I have x squared plus 3 plus the square root of 6x is equal to 0, and x squared plus 3 minus the square root of 6x equals 0. So for both of these, because both of these are quadratic equations, you can use the quadratic formula to solve them. So by using the quadratic formula, I'm actually not going to do that in the video, but you can try that yourself. You should get that x is equal to the square root of 6 times negative 1 plus I over 2, and x is also equal to the square root of 6 times negative 1 minus I over 2. And also, along with this, you should get x is equal to the square root of 6 times I plus 1 over 2, and x is equal to the square root of 6 times times 1 minus I over 2. So these are your four solutions.